Remember this question?
Hmm?
In a triangle ABC, AD is the median. Okay,
Yeah.
BD is equal to DC, and AB square plus AC square is equal to M times AD square plus BD square. Now you have to find M.
A B A C. Okay.
How would you like? First of all, look at we. First of all, in any question, we have to look at what we have to find or what we have to prove. Okay, and then make the necessary constructions or like observe that the given values can be derived by what method or what theorem, and if sufficient condition is there for us to apply that theorem, we apply that theorem. Otherwise we create those necessary conditions by making some constructions, create those necessary conditions for the application of that theorem through which anything can be derived out, and then try to derive the whole thing.
Does AD equal root times BD times BC or DC? BD times DC root is equal to AD, right?
AD is equal to under root BD into DC.
Yeah.
What property is that?
The wait, no, that's the altitude. Yeah. So we can't do that.
See, look at what we have to find out. We have to find out something in terms of sum of squares of sides. And there is only one theorem in the world that directly gives you that relation.
Pythagorean?
Yeah, exactly. So you have to apply Pythagoras theorem here.
Okay.
That is why I am telling you to analyze what we have to find out. And if the necessary conditions are not present in the diagram, in order for us to have that Pythagoras theorem which is needed here, then we make that thing by ourselves. We drop a perpendicular, we drop an altitude so that we can apply Pythagoras theorem. Okay, what was the construction? AL perpendicular to BC. Now, if we are going to apply Pythagoras theorem on the left hand side, what do we want? We want AB square plus AC square. First of all, AB square would be equal to AL square plus BL square. Is that right?
Mhm.
And AC square is equal to like again AL square plus CL square. Right? And if we are just going to add these two
So
equations out,
M equals 2.
M is going to be equal to 2. But how? This will become 2AL square plus BL square plus CL square. But we want on the right hand side AD square plus BD square.
Okay.
How to get that? After this,
AD,
now what?
hmm?
After this, now what?
AD squared plus BD.
Anyway, we don't want L to be a part of our final answer because this is what we have constructed by ourselves.
Yeah.
So anything containing L cannot be a part of our final answer. So we have to eliminate L. So let's start with eliminating L from these two terms. Okay,
Hmm.
this would be, let's not mess with this AL's 2AL square right here. But yeah, BL we can write it to be equal to BD plus DL whole square, right? And CL
Hmm.
we can write to be CD minus DL whole square. Is that right?
Yeah.
Now this is going to be equal to 2AL square plus BD square plus CD square plus 2DL square plus 2BD into DL minus 2CD into DL. Is that right?
Yeah.
Now we know that BD is equal to CD. And if that is the case, these two terms would get cancelled out with each other.
Yeah.
So this becomes 2 times AL, let's put AL and DL together. Okay. And this becomes 2 times BD square. And what is AL square plus DL square? Again,
AL
AL
squared plus
square.
DL squared.
Yeah.
1
Look at the
half
figure.
AB squared plus AC squared.
No, no, no. Look at the figure. What is AL square plus DL square?
AL squared plus DL squared
Yeah,
is DA squared, or
exactly. This is
yeah.
also 90 degrees, right? So in this right angle triangle, this is going to be equal to AD square. So this was what? We have put AL square and DL square together, right?
Mm-hmm.
This becomes 2 times AD square plus 2 times BD square was there.
Yeah.
Therefore, M is equal to 2. Answer.
Yeah.
Okay.
I see how you did that, but I like use the same 6, 8, 10 thing.
Now, see that is the trick, and trick all doesn't work always in all the questions.
Yeah.
Therefore, I'd like you to like apply your theorems, whatever you have learned up until this point.
Okay.
That would be a better way to own up your skills and take them to the next level. Because trick is not going to be like a way to find out the solution for every question in the examination, right?
Yeah.
Okay. Was this a good question again? See, this
Mm-hmm.
was the most important part. Like even constructing this perpendicular and applying Pythagoras theorem was okay. Like we have to get something in terms of the sum of the squares of the side lengths. Therefore, the only theorem that can give us a relation like such is Pythagoras theorem. And if no 90-degree was there in the question, we have constructed one ourselves and applied Pythagoras theorem like this. And how to apply that? First of all, on the left hand side, we wanted this AB square plus AC square. So I have created both the terms using these two right angle triangles. And on the right hand side, when we have gotten this, now from this, how to go to this? This was the most important step. So what we did, we have written, because we know that BD is equal to CD and we have to make use of this property. So we have to convert this BL and CL in terms of BD and CD respectively, so that the DL is going to be the common term. And again, these two got cancelled out. We have written these two BD square to be equal to this BD square and CD square to be equal to 2 BD square, and this 2 DL square, which we have also gotten, we have paired it with AL square, so that because in this right angle triangle, AL square plus DL square is equal to AD square, and alpha and our final result was there, right?
Yeah.
So converting this thing to this thing was the main part. Kindly take a good look at the whole thing and tell me in case of any doubts, and we'll move further. Okay. So yeah, in this triangle ABC, this is point E,
Okay.
and this is point D. Join this EC and this AD as well. Okay. Now uh, we have been given that AE is to EB. This is equal to 1 is to 3. Okay. And BD is to DC. This is equal to 5 is to 3. Now you have to find, let's say the intersection is point G, EG is to GC. Okay. Any ideas how to do this one?
EG to GC.
Yeah.
Okay.
See, if anything in terms of that is what I would like want you to observe in every question. What we need to find out, and then after that, how are we proceeding? Like in this question, greater than the sum of side lengths, something like that. So we had to apply the inequality, triangle inequality. Okay. Here sum of squares of sides was there, so we had to apply Pythagoras theorem. Okay. And if we have to apply, if we have been given something in terms of the ratio of sides, then the only theorem that gives us that is something in terms of the ratio of sides,
Mhm.
similarity of triangles, or basic proportionality theorem. Do you remember basic proportionality theorem?
Yeah.
Like if this is a triangle ABC, and this is a line that is dividing the, let's say DE, which is D is dividing AB in the ratio k is to 1, and E is dividing AC in the same ratio k is to 1. Then DE is parallel to BC, and we can write AD upon BD is equal to what? AE
Yeah.
upon EC, AE upon C, right? This was the basic proportionality theorem.
Yeah.
Okay, so like that we have to make something out here as well, because AE is to EB is given, right? This is 1 is to 3. Let's say this is x, this is 3x. This is 5y, this is 3y. Right?
Mm-hmm.
Now we have to find EGs to GC. So again, we have to apply that. And to apply that basic proportionality theorem, we would like to have a what? A parallel, uh, a parallel thing, right? And if we are going to join this ED, we are not at all sure that whether or not this ED is going to be parallel to this AC. And let me prove to you it would not be, because if we are joining ed, then this is 3 is to 1, and this is 5 is to 1. So this e is dividing, like this d is not dividing bc in the same ratio at
Yeah.
which e is dividing ab. So it means this ed can never be parallel to ac. Okay. So if not this, let's construct something different, like this. Okay, let's name this point M. So this was the construction EM parallel to AC. Nisha, I'm again telling you that I just don't want you to give, I just don't want to give you the solutions. That this construction you have to make in this question, that construction you have to make in that question, and something other you have to construct in another question. I want you to understand the meaning of that construction. Why have we constructed anything like that? Why only this construction? Why only this parallel to this? Why can't be anything this parallel to this? That can also be a question, right? Hello?
Yeah. Yeah.
Why only this parallel to this and why not this parallel to this? Yeah, that can also be a question.
Yeah.
Why not construct an EM such that it is parallel to AD right here? Right?
Yeah.
Why only EM parallel to AC? And that is a correct question actually. This would be a wrong construction. Like, let me not just tell it to you that it is a wrong construction. Let me prove it to you. So if we have constructed something like this, then this is also going to be what? 3 is to 1. Is that right? Because this EM is parallel to this AC. So if this is 3 is to 1, this would also be 3 is to 1.
Oh,
Then
okay.
that be right.
Yeah.
Okay. And BC is equal to what? BC is equal to like 8y. And BM is equal to 3y4 of BC. Is that right?
Yeah.
It means BM is equal to like 6y.
Mm-hmm.
Is that right?
Yeah.
Okay. Now we have successfully made use of this 3 is to 1 ratio. But what about this 5 is to 3 ratio? How can we use that? Because we have to find something in terms of EG is to GC, right? So in order to apply like find out EG is to GC, we would have to apply the same theorem, the same parallel theorem in this triangle as well. But we all know that this EM is not parallel to this AD or GD. This EM is parallel to this AC. Therefore, this was a wrong construction, and we have to construct something like this EM, something like this, so that EM now is not parallel to this AC, but it is parallel to AD. Because again, we will be able to apply the same thing. This is 3 is to 1, so this would be 3 is to 1, right?
Yeah.
This would be 3 is to 1. And not only that, but we would also be able to apply the same theorem in this triangle. Because in, wait a second, in this triangle. Because in this triangle, these two are parallel to each other. So this is to this would be equal to this is to this. Am I
Oh,
right?
yeah.
That is why this would be the right construction. Kindly write it down. Why AM parallel to AC is not the, sorry, why EM parallel to AC is not the right construction to make. If you want me to repeat everything, I'll repeat everything. Just let me know, okay?
Can you repeat the last part?
Uh, what last part? Can you specify?
Like why we did the EM.
Okay. See, EM parallel to AC if we have drawn, then it was very good. This was 3 is to 1. And we were able to find this BM. This BM we were able to find. But what we'll do with this BM, because if we have to find EG is to GC, then in this triangle, we have to have these two side lengths parallel to each other such that EG is to GC is equal to again MD is to DC.
Okay.
Thayer's theorem, that basic proportionality theorem, not only do we need to apply in this triangle, but also we have to apply in this triangle as well.
Oh, okay.
So for the same line, this once this whole part was used, this parallel to this, and for the same line, this part of the whole line was used, this parallel to this. So that EG is to GC, we had to find out that is equal to MD is to DC. Okay.
Mm.
Okay. By Thayer's theorem, we can write BM is to MD is equal to 3 is to 1. And we know, have you written down everything?
Yeah, I'm writing it
Okay.
down.
And we know BD is equal to 5y, right? And MD is equal to what? 1 by 4 BD if I'm not wrong.
Yeah, that's
MD
right.
is equal to 1 by total 3 plus 1. BD is 3 plus 1 and MD is 1. So 1 by 4 BD is equal to MD. That is what I have written here as well.
Yeah.
Okay. It means MD is equal to what? 1 by 4 into 5 5. Okay. So MD side length we have successfully found out. Now, again, in this triangle, let me write it over here. Again, in triangle ECM. EM is parallel to triangle ECM. EM is parallel to GD, right? Therefore, again by Thayer's theorem, EG is to GC is going to be MD is to DC. Is that right?
Yeah.
EG is to GC is going to be MD is to DC.
Oh,
So, if that is the case, then what is MD? MD is 1 by 4 into 5 by. What is DC? This is 3 by. Right?
yeah.
It means EG is to GC is going to be 5 is to 12. Answer.
Oh, okay.
Okay?
Yeah.
Take a good look at the whole question yourself and try to understand the whole concept all at once. Tell me in case of any doubts, and we'll move on to the next question.